Hello and welcome to this talk about the ICSME 2020 paper IFDEF Directives and Program Comprehension, the dilemma between correctness and preference. Hopefully you will find this talk interesting enough to read the full paper and ask some questions at the conference. My name is Wolfram Fenske and I'm currently a consultant at Pure Systems, the makers of the variant management software Pure Variants. However, this presentation is about work that I did as part of my PhD studies at the Otto von Guericke University of Magdeburg in collaboration with Jakob Krüger, Maria Konischkova and Sandro Schulze. So, what is this work about? Many organizations and open source software projects use the C preprocessor to implement fine-grained static source code configurability in their software systems. Essentially, this means enclosing some lines of code in IFDEF directives, as shown here, and depending on how the code is compiled, these lines become part of the final product or not. There are cases when there are several ways to structure the CPP directive, though. Let's take another look at this listing. What's shown here is actually called an undisciplined directive because the annotated code is not a proper C statement by itself. Some developers don't like using CPP directives in this way, and so there are refactorings to turn disciplined directives into undisciplined ones. As this example illustrates, there are different styles of using CPP directives, and there are also refactorings to turn one style into the other. The question we try to answer in our paper is how such refactorings affect program comprehension. There is extensive research that tries to answer this question, and among other things, this research has found that disciplining directives allows developers to solve comprehension tests faster and more correctly, and in addition to such objective measurements of program comprehension, other research has uncovered that developers subjectively prefer disciplined directives. So what are the limitations of the existing experiments? Well, we see two things. First, almost all of these experiments either measured the participants' objective comprehension performance or they asked about subjective preferences. However, almost none measure both using the same code examples and the same group of participants. Secondly, when it comes to objective comprehension performance, most experiments relied on a small number of inexperienced developers, usually computer science students. But how well do these results translate to experienced developers? Here's what we did. We created a questionnaire that was completed by 521 software developers who we contacted through GitHub. Most of these developers were between 27 to 42 years old, and their programming experience was 20 years on average, with around 15 years of experience in C and C++. So it's fair to say that we had a large number of participants who were highly experienced. Our questionnaire was built around code examples taken from the open source text editors Emacs and Vim, and we manually refactored these code examples in order to simplify the CPP directives as follows. If a function essentially comprised two alternative implementations, we split this function into two alternative definitions. If a function contained undisciplined directives, we disciplined them. And finally, if a compile time ifdef was mixed with a runtime if, we refactored it so that only compile time ifdefs were used. However, that last refactoring was used only once in the Vim example that you see on the slide. So we had two code examples each from Emacs and from Vim, and all of them were refactored, yielding 8 examples in total. Based on these code examples, we created 2 questionnaire variants and distributed the examples such that each participant saw 2 original examples and 2 refactored examples. In addition, we inserted a baseline example at the beginning, which was the same in both questionnaires. That way, we could establish that both groups of participants were comparable in terms of their performance and subjective opinions. And now that we know about the code examples, what about the tasks and the questions we asked? For each example, there were 2 program comprehension tests, and in the first test, the participants were given a list of statements and had to decide which of these statements was true. In the second test, the participants had to mentally configure the code, and this means they were given a list of conditions and had to select the ones which would cause a particular line of code to be executed. And following these comprehension tests, there were a number of questions in which the participants had to rate the code example regarding the appropriateness of the CPP directives in particular and the code quality in general. So now comes the big question: did these refactorings improve program comprehension or not? Well, the responses that we received were surprising. Contrary to our expectations, the developers who worked on the refactor code failed to perform better in the comprehension task. In fact, they performed slightly worse, especially on the second task. But at the same time, they rated the use of CPP directives in the refactored examples as more appropriate. However, regarding code quality overall, the refactorings did not seem to have much of a positive effect. So at first, we thought these results were a big letdown, but on second thought, they represent a rather interesting dilemma. Even though our participants preferred the refactored CPP directives, their comprehension performance in terms of correctness didn't improve, and in fact it got slightly worse. So what should we do then? Should we refactor CPP directives even if program comprehension might actually worsen? And what about the risks of breaking the code while doing that? And are improved aesthetics really enough of a reason to refactor? To summarize, we performed a large-scale empirical study involving highly experienced open source developers, and in the study we analyzed how refactoring CPP directives impacts program comprehension both objectively in terms of correctness as well as subjectively. Our results uncovered a surprising dilemma. In line with existing findings, our participants preferred the way in which the CPP directives were used in the refactored example, but at the same time, and this is the interesting part, they failed to perform better on the refactored code in the comprehension tests. Even though our findings are by no means definitive, we believe they raise some interesting questions about CPP usage that future work should investigate further. A replication package with our dataset is available for use in your own research, and I hope this presentation made you curious enough to read the full paper and learn more about the details of our study and its results. My name is Wolfram Fenske, and I look forward to seeing you at this year's ICSME.